Hi folks, JAGMIR here today. So today we're going to talk about stoichiometric conversions, but before we even get to that, it's really important to understand the three-way relationship between the moles of a substance, its atomic mass, and Avogadro's number. So in this particular case, we're considering carbon. So we're going to put 1 mole of carbon up here. As you can see, we're putting equal signs. This is the atomic mass of carbon, and as you can see, you see Avogadro's number of atoms of carbon over here. Notice that these three things are equal to one another, and this is essential before you move on to the next step of creating conversion factors. Now, before you even go there, it's also important for you to realize that we can change this from carbon to any element on the periodic table. So let me change that to nitrogen, for example. 1 mole of nitrogen is the atomic mass of nitrogen. That in turn is also equal to Avogadro's number of nitrogen. So we can essentially do this with every single element in the periodic table. 1 mole of any element is equal to its atomic mass, and both of those are equal to Avogadro's number of atoms of that element. Okay, so in the next video you'll see that we'll be creating conversion factors from this three-way relationship. Now, before I go, I also want to talk about molecules. So if you consider a molecule like carbon disulfide, for example, and it's a carbon, central atom of carbon with 2 sulfur atoms on the sides. The molecular weight, now notice that we're talking about a molecular weight here. We're going to need that is calculated to be 1 carbon and 2 sulfurs at 76.15 grams of carbon disulfide. Now, how did I come across that number? Well, basically it's 1 carbon and 2 sulfurs. Okay, so each sulfur atom is a mass of 32.07, and carbon is 12.011. You add those together and you come up with a number of 76.15. Okay, so let me just move the board a little bit over here. So as you can see, this is how we came up with a molecular weight of carbon disulfide. So that aside, we can use this for molecules of what as well. Avogadro's number stands. So Avogadro's number of molecules of carbon disulfide. So 1 mole of carbon disulfide is going to be equal to the molecular weight of carbon disulfide, and that in turn is equal to the number of molecules, Avogadro's number of molecules of carbon disulfide. So be aware that you can use this three-way relationship for essentially anything in chemistry. Okay, so in the next video you'll see that how we use this for conversion factors and how to derive ratios. And so please click on that button down there and subscribe to my channels for more videos to come.